Alright, so let's take a look now at problem number 2. This is all in preparation for an upcoming quiz over that skill 6 with the radicals, with addition of radicals, subtraction of radicals, multiplication and division of radicals, and simply evaluating radicals. Alright, so we have a fraction again. Now this time in the denominator we have two terms, and again we see radicals in the denominator, and we're not allowed to do that. So this time I can't simplify the square root of 2 like I did in problem 1 by simplifying the square root of 16. So we have to approach it in another way. There's an idea that's called the conjugate, that if you have two terms, you change the operation. This is addition, and we're going to do the inverse and do subtraction. So the basic idea is I'm going to multiply this fraction by the number 1. And you see that a lot in algebra. You know, that if you have 1/2 and you need a different denominator, say I multiply by the number 1, but I write 1 as 3/3, then I know that this 1/2 that I started with is the same number as 3/6. They're equivalent. Even though visually this number looks different than this, it reduces to the same value. It's the same point on a number line. If you did 1 divided by 2 on your calculator, you would get 0.5. If you did 3 divided by 6 on your calculator, you would get 0.5. So it represents the same number. Well, we're going to do the same idea, but only to this more complicated fraction. So I'm going to multiply this by the number 1. And the number 1, just like we had 3/3, the numerator and the denominator have to be equal to each other, and 0 divided by 0 is not allowed. That's the only one that you can't have, is you can't have a 0 in the denominator. So the conjugate of this 2 radical 2 plus 4 radical 3, we change the operation, we change it to the inverse, we change addition to subtraction. The numerator and denominator have to be the same for this to be the number 1. So when I multiply these two fractions together, the result that I get is going to be equal to the original fraction. Alright, now in the numerator I can just distribute. I can take this 5 radical 5 and multiply it by the 2 radical 2. So I can multiply the numbers on the outside of the radical, 5 times 2, and get 10. And then I can multiply the numbers underneath the radical, 5 times 2, and get a 10, but it has to be underneath the radical. So now I distribute over the subtraction, and I multiply the next number in this binomial. So I multiply the 5 times the 4, the numbers outside of the radical, and then underneath the radical, 5 times 3 is 15. And see, when I try to break down 10 and 15, I don't get a pair of numbers, so I can't simplify the square root of 10 and the square root of 15 any further. So that's going to be the numerator of my answer. Now, to figure out this denominator, I need to multiply this and this together. They're conjugates. I'm going to do it in the form of a table, and what I'm going to notice in this table, because these are conjugates, is that one of the diagonals, the numbers are going to cancel each other out. That's always going to happen when you multiply conjugates together. So let's put this first binomial over on the left, and let's put the second binomial across the top, and then we can enter in the values in our table. For those of you that are doing FOIL, the first terms times each other is just this first box. Then the outside terms, the 2 radical 2 and the negative 4 radical 3 is this box, and then the inside terms, when you multiply them together. So the table really is FOIL. It's just doing it, organizing it in a table rather than than writing it out horizontally. Alright, so when we multiply these values together, we multiply outside the radical, the 2 times 2, and I get 4. And when you have radical 2 times a radical 2, hey, that's square root of 4, which is 2. So I have 4 times 2, and I know that's going to be 8 in just a minute, but I'm writing it like that so you can see where it came from. The positive 2 times the negative 4 is a negative 8. And this time when I take the square root of 2 times the square root of 3, I get the square root of 6. I can't simplify the square root of 6 like I did the square root of 4. Now on this inside term, since this was negative 8 radical 6, I'm expecting to get a positive 8 radical 6 here. Let's see if I do. 4 times 2 is 8, and square root 3 times the square root of 2 is the square root of 6. So those are equal and opposite. So when I add those together, I know this negative term and that positive term are going to cancel each other out, which is what I wanted, because the whole idea of multiplying by the conjugate was to get rid of the radicals in the denominator. So now when I multiply these two radicals together, the positive 4 times the negative 4 is a negative 16. And the square root of 3 times the square root of 3, hey, that's the square root of 9, which is 3. So when the numbers are the same, they pair up and the radical goes away. Alright, so now in this denominator, let's shrink this up a little bit. I have 8 minus 48, which is a minus 40 here. So you might think that we're done, but if you take a closer look at the numbers in our fraction, they're all even numbers, the 10, 20, and negative 40, so we can write this fraction in lowest terms. Now you have to be careful when you have two terms in the numerator. You can't just come in and cancel terms, because both of these numbers are being divided by negative 40. What I can do is look in the numerator and say, well, these two terms, what do they have in common? I'm going to factor it. Well, they have a 10 here, and 20 is 2 times 10. So when I factor out a 10, I just have 10 times 1 is 10. I have this 10 radical 10 minus, well, 10 times 2 is 20, and then I have the square root of 15. Now in the denominator, I can rewrite negative 40 as positive 10 times a negative 4. And now I have this 10, and since this is a factor and it's not addition or subtraction there, I can say 10 divided by 10 is 1, and that those cancel. And I can say that my final answer, that when you take this original fraction that we had, and after you've multiplied by the conjugate, you have a new numerator and a new denominator. Now, I claim that these two numbers are equal to each other, and I can check that on a calculator. I can take this 5 times the square root of 5, and I can, I can divide it by this denominator, and now I need parentheses to tell it that that's my whole denominator. So my decimal approximation, this is an exact value, and the calculator can approximate it for me, but a pretty good approximation to about 9 decimal points. Now if I need to put my numerator in parentheses. If I take the square root of 10 minus 2 times the square root of 15, close that because there's my entire numerator, and divide it by negative 4, I should get the same decimal number. And I do, so I'm fairly confident that this final answer is correct, that these two fractions are equal to each other, but my answer doesn't have a radical in the denominator. So I hope that helps.